Chapter 7 is on linear equations and graphs, and this is the lesson video for section 7.1 on the slope-intercept form. So what's the big deal about linear equations? Well, we make sense of our world by understanding how things are related, and one common relationship is the linear relation, and it's often expressed as an equation. Now, there are other ways that things can be related in the world that don't create a linear relation. There are quadratic relations, it's another common one, sinusoidal relations, and lots of other different types. But in this chapter, we're just focusing on linear relations between two variables. They're very common and they occur all the time. In chapter 7, our learning goals are that we're going to be able to graph a line using a variety of methods, determining the equation of a line using characteristics of the line, and then converting the equation of a line from one form to another. And in fact, there are 3 different forms that we can write a linear equation in, and you have to be able to convert between all 3 of them. And then model and solve real-life problems using a linear equation. If you're wondering what the pictures are at the bottom of your page, there is an investigation in your textbook where they look at an old mystery of the disappearance of some people and how they're trying to solve that. So I thought it was pretty interesting. You might want to check it out. So in section 7.1, the slope-intercept form, we're going to be looking at one specific type of way to write a linear equation. And this one leads from slope that you learned in section 6.5. So we're going to be identifying the slope and y-intercept of a straight line graph, determining the linear equation using the slope and the y-intercept, rewriting other linear relations into slope-intercept form, graphing equations that are given to you in slope-intercept form, and so you're given an equation, you have to draw the graph, and then solving problems using these equations. So some real-life examples that could be used just to describe a linear relation. There are tons of examples, and we would brainstorm this in class, but some examples that maybe have come up in previous chapters are like comparing degrees Celsius to degrees Fahrenheit, how distance changes over time, so it's a speed graph. Water pressure, like as a diver is diving down, the water pressure gets greater at a constant rate. There's so many examples for linear relations that we could come up with a huge list. So as the name suggests, the slope-intercept form of a linear equation requires that you know the slope of the line. So just a quick review of what slope is from section 6.5. Slope is the ratio of the vertical change, or the rise, to the horizontal change, or the run, of a line or line segment. A line is just like a line that goes in both directions forever, left and right forever, and a line segment is just a piece of a line. Slope is the rate of change of the line. So the rate of change, how steep or how fast it's increasing or decreasing. So it's that ratio. And when we write the slope as a formula, m is the variable we use, and it's equal to the rise, so the change in the vertical change, over the run, the horizontal change. And in symbols, we use that delta, which means change in. So the rise is the change in the y values, and the run is the change in the x values. And another way to look at that is if you have 2 points on a line, you can write the equation where you're finding the difference between the 2 y values of 2 points and divided by the difference of the 2 x values from the 2 points. So that equation, that y2 minus y1 over x2 minus x1, is the slope formula if you're given 2 points on the line, where 1 point is x1, y1, usually the point more to the left, and then the point more to the right is its coordinates, or the x2, y2 values. slope is never expressed with units, so there's like it's just a number that is expressing the rate of change. So an example is from this graph that's just below the box here, and it's just showing how you have your 2 points, x1 and y1, and x2, y2, and how it's you're finding, the change. The rise is the change in the height, and the run is the change in the horizontal. All right, so the slope is one piece to the equation that we need. The other piece to the slope-intercept form is the y-intercept. So that's where the intercept part comes in the name. So the y-intercept is the y-coordinate of the point where a line or curve crosses the y-axis. So it can be a line or a curve. It's any graph, whether it's straight or not. Where a graph crosses the y-axis, the y value is the y-intercept. So any point any point that's lying on the y-axis has an x value of 0. So when whatever the y value is, when x is equal to 0, that is your y-intercept. The value of y when x equals 0. And if 0 comma b is the point where the graph crosses the y-axis, then b is the y-intercept. So as a variable, we can't use y because y is a value in any coordinate on the graph. So specifically, the y value at the y-intercept, we use the b as a variable for that. So in this graph here, this one on the right, if we're going up by ones here, the y value when x is equal to 0, this y value is 3. So the coordinates is 0, 3, and that's the y-intercept would be equal to that y value of 3. Now, similarly, there is also an x-intercept for graphs. If a graph crosses the x-axis, that x value is equal to the x-intercept. But in the slope-intercept form for a linear equation, we are using the y-intercept for that equation. All right, so we've talked about all the parts now to set this up, but what is the actual slope-intercept form of a line? The slope-intercept form is the equation of a non-vertical straight line in the form y equals mx plus b, where m is the slope and b is the y-intercept. So there it is, y equals mx plus b is the equation in slope-intercept form. So the m value is multiplied by the x, that's your slope, and the b value is being added to that m times x, and that is your y-intercept. So we often use y-int as a short form for y-intercept. So you'll see that a lot more. And so that b value, again, from the previous slide there that we talked about, when x is equal to 0, the y value on the graph and at that point is that b value or the y-intercept that you sub in. Now, if your y-intercept is negative, you're adding a negative value to that equation. So adding a negative does become subtraction. So just keep an eye out for that. So let's practice identifying some different slopes and y-intercepts given equations of a line. So for example 1, part A, we have y equals 2x plus 3. All right, so in the number being multiplied in front of the x is your slope. So m, or slope, is equal to positive 2 here. Now, slope is written as rise over run as a ratio. So if you just have a whole number there, you could write it as a fraction by putting it over 1. So that 2 over 1 is the slope, and that means that on your graph, the rise of the graph is equal to 2 as the run is equal to 1. So for every 2 spaces it'll go up, and then it'll go to the right 1. and then that's the next point on the graph. The b value here, we have to look at the sign for the constant term in the equation because that tells us the sign of the y-intercept. So the b value is positive 3 here, and we would then say that the y-intercept is equal to positive 3. So that actually gives us a point on the graph. 0, 3 is a point on this graph. All right, so looking at example B, identifying the slope, again, we have a positive 2 multiplied in front of the x, so your slope, or m, is 2, or you can write 2 over 1 if I need you to identify the run. Otherwise, just say it's 2. And then your y-intercept is equal to the b value. Now notice how it's minus 5 as the constant term here. So the b value, or the y-intercept, would be equal to negative 5, because you'd be adding negative 5 into the equation. Y equals 2x plus, and then that negative 5. But when you're adding a negative, that's what I was saying earlier, that just becomes subtraction. So 2x minus 5 means the same thing. So that point 0, negative 5 is a point on your graph. For example C, just move up a little bit, we have, now it appears that we don't have a number in front of, or multiplied in front of the x value or term here, but we do. So when there's no number written in front in a multiplication, that means that we're just multiplying it by 1. So it's not that this line would have no slope. The slope would actually equal 1, or 1 over 1. Just get rid of that. So the rise and the run is 1, right? The rise is equal to 1 and the run is equal to 1. So it is going up and over 1 each time. So there is slope to a line that has a slope of 1. And then your y-intercept, again, oops, I clicked on my highlighter. Again, the b value is being there's subtraction there, so our y-intercept is equal to negative 2, and we know that 0, negative 2 is that point on the graph. Okay, going up to example D, y equals x is our equation, and again, there's no actual number written in front of the x, so that means there's a 1 there, so the slope equals 1. And for the y-intercept, if there's no constant term written with the x term, there is still a y-intercept. Every line, unless it's vertical, every line will have a y-intercept, no matter what. So if there's no number actually written there, I always ask, well, what number would you add to something to not actually change the number? And that would be 0. So the y-intercept of this graph is 0. You could write plus 0 there and it doesn't change anything. And that means that when x equals 0, y equals 0. So the graph's y-intercept would be at 0, 0. So if there's no number written there, there is still a y-intercept. For example E, we have negative 2/3 being multiplied in front of the x. So our slope is negative 2/3. So that means it's decreasing as you go left to right, right? The rise is negative 2 when the run is positive 3. And for the y-intercept, we have, we're adding 5 as the constant term, so that y-intercept would be positive 5, and 0, positive 5 would be the point on the graph. And lastly, for example F, we have negative x, so that means our slope would be negative 1, because this means like negative 1 times x here, and it would still be over positive 1, the rise would be equal to negative 1, and the run would be equal to positive 1. And the b value, or the y-intercept, is that constant term, which is positive 1. So 0, positive 1 would be the y-intercept and a point on the graph. Now there's also a chart on page 344 in your textbook for more examples of slope and y-intercept that you could check out if you would like. All right, so for example 2, we're given a graph of a line and they want us to write an equation for this line in slope-intercept form. So in order to do that, we need to look for a few things. Well, in slope-intercept form, we need to know what the slope of the line is and we need to know what the y-intercept is. Once we have those two pieces of information, we can sub them into that equation. So using your graph, find the y-intercept. And using your graph, find the slope. Now you might need to find 2 points on the graph and calculate your slope using y2 minus y1 over x2 minus x1 formula. Then once you know those two values, sub it into the equation, y equals mx plus b. You can always check your equation by actually graphing it in your calculator or on paper by creating a table of values and compare it to make sure it looks the same as the graph you were given. So from the graph we're given here, we'll start by looking at the y-intercept. So they give us a scale here, and each space, so there's 10 spaces and they've labeled it as a 10. So each space is going up by 1. So the coordinates of the y-intercept would be at 0, because x is always 0 at the y-intercept, 2, 0, 2. So that means our b value would be equal to positive 2. Okay, so now we can use that point as a point on the graph, and then go down your graph and look for another point that crosses exactly at a coordinate. Okay, so here would be one. You could go backwards as well and look, and here's one here. So pick one of those points. I'm going to use the x-intercept because the y value is 0. So at x equals 3, y is equal to 0. And those are nice numbers to sub into my slope equation to solve for slope. So y2 minus y1 over x2 minus x1. If I say this is my first point, number 1 on the left, and this is my second point, so it gives me y2 would be equal to 0, and then subtract y1, which is positive 2. Now this line is decreasing from left to right. So we'll notice that when we sub in those numbers, 0 minus positive 2, we're going to have a negative number in the numerator. Well, that's a good thing because our rise should be negative. And then x2 would be your 3 value, and then minusing x1, which is 0. So that leaves us with negative 2 over positive 3. And that would be the slope of this line, or the m value. So if we go back over to y equals mx plus b, in our equation, we always have y equals, and we have an x, because those are our variables. M and b are letters, but they get numbers subbed in for them. So we call those letters parameters in an equation. All right, so the parameters, m, slope, is negative 2/3 times by the variable x, and then the b value is positive, so it's plus 2. So the equation, y equals negative 2/3 x plus 2, is the equation that would describe this line above. Now, on your calculator, if you want to type this in and graph it on your calculator, I'll just give a quick version of how to do that. If you have a TI 83 or 84 plus graphing calculator, your steps would be, so on your calculator, okay, so you're going to press the y equals button on the top left, kind of just below your screen on the left side, and then it's going to bring you up a screen where you can type in equations. So in the first spot where it says y1, you're going to type in the right side of the equation, so everything that y was equal to. So you'll have in the y1 equals spot, your cursor will be flashing. Press a bracket. Always type fractions in brackets in your calculator. So bracket negative 2 divided by 3, and then close your bracket. Make sure you use the negative key, not the subtraction key, or else this won't work. Then type in your x variable and then plus 2. Then you can press the graph button, which is under your screen on the top right, and it will bring up your windows. Window settings will be 10 by 10 by negative 10 by negative 10. Window is just how much axis is showing in your screen, and your graph should look something like what we have above. Now that is a really quick version of how to graph on your calculator. We will be doing a lot more of that as we go along. All right, so now you can try the your turn question from page 344 in your textbook. So I've included it in the notes here. And so part A is, what is the slope and y-intercept of the line shown in the graph? And then what is the equation of the line? And check your answer using your graphing technology. So pause the video here and give this question a try, just like the example above, example 2, and then press play again to see the solution. All right, so looking at your graph, it crosses the y-axis at the point 0, -1. And so that is your b value, -1. And then going up the line to the right until I find another point exactly with exact coordinates would be at 4, 2. And so that I can use that as my x2, y2. And subbing those 2 points into my slope equation, I'll have 2 minus -1, careful with the signs here, and then 4 minus 0 on the bottom for the run. And that leaves me 2 minus -1 is equal to +3, and then 4 minus 0 is 4, so my slope is 3/4. Subbing m and b into my equation, y equals mx plus b, I would get y equals 3/4x minus 1. So at the top of the next page, you'll see that I've given you the steps of how to type or graph on your TI graphing calculator. I also have a separate tutorial video for so I actually show you how to graph on your calculator. And if you don't have a TI calculator, you might just have to refer to your manual to figure out how to graph on that, or search YouTube. I'm sure there's somebody made some tutorial videos. I also have a separate video actually, of how to adjust the window settings to be able to see or zoom in or zoom out on your graph. So I will post those videos with this video. All right, so example 3 is converting an equation into slope-intercept form. So this is an equation given to us that is not in y equals mx plus b form, and we want to convert it into that form to tell us the slope and the y-intercept of the line. So just the Student Council is renting portable dunk tanks as a fundraising activity. And so the relationship between the number of balls thrown, which is x, and the profit, y, in dollars is represented by the equation 3x minus 2y minus 600 equals 0. Convert the following equation into slope-intercept form. To convert an equation into slope-intercept form, you must use algebra to rearrange the equation to get y by itself on one side of the equal sign. And as it is right now, this equation doesn't tell us anything very useful about the equation or the graph of this line. So it is a way to write the equation of a line, but it's called general form and it doesn't tell us much about the line. So to get the slope intercept form, y equals mx plus b, we need to get the y by itself on one side of the equal sign, and then we can see what the slope and the y-intercept for the graph are. So to rearrange this equation to get y by itself, we want to move the other terms to the other side of the equation. So to move the 600 over, we'll undo the subtraction by adding 600 to both sides. And I'll do it in separate steps. So we're left with 3x minus 2y on the left side equals 0 plus 600, which is just 600 on the right side. Then move the x term. So the x term is positive, so we'll subtract the whole thing. So 3x minus 3x would just equal 0x. So 0x minus 2y just equals negative 2y. So what we do to one side, we have to do the same to the other. Now we typically write the x term first. So we would have negative 3x and then plus 600 on the right side. Then now we have the y term by itself on the left side of the equation. So now we can undo this multiplication of what's being multiplied by y. So we will divide by negative 2. Negative 2y divided by negative 2 just equals 1y. And then what we do to one side, we have to do the same to the other. Now, it's when we're adding or subtracting, we just do it once to like both sides. When you're dividing, you have to divide the whole thing by negative 2. And if you remember your polynomial rules, that means that every term gets divided by negative 2. So negative 3x divided by negative 2, negative divided by negative is positive, 3 divided by 2 is just 3 over 2, and then the x is still there, and then positive 600 divided by negative 2 would leave us with negative 300. So our equation in y equals mx plus b form is y equals 3 over 2x minus 300. So using this slope-intercept form, what is the slope and what is the y-intercept, and what do they represent in the context of the question? So the slope of the line is the number in front of the x value, so the m, which is equal to 3 over 2. And what does it represent in terms of the equation? Well, if you remember, slope is rise over run, and it told us in the question that x was the number of balls thrown and y is the profit in dollars. So the slope is representing the rate that they're making money the rate they're making money kind of per ball. So the slope is equal to 3 over 2, which is 1.5. So the slope is representing an income of $1.5 or $1.50 per ball. The slope is positive because money is coming in. The y-intercept for part C is from the constant term, so the b value is the y-intercept, which is equal to negative 300. And what does that mean in terms of the question? It means the y-intercept is the initial cost before any actual money is brought in by people throwing the balls. So because it's a negative $300, they're in debt. $300 at the start, and that's probably what the dunk tank actually cost before they started selling tickets for people to throw the balls. And for part D, it's asking what is the x-intercept of the line? So what is the x value when y is equal to 0? And that will be something you can sub into the equation and solve. So you can use the original equation, or you can use the equation you rearranged, the y equals mx plus b form. It doesn't matter. So if we use y equals mx, or the mx plus b form, we would have y equals 3 over 2x minus 300. So we're trying to solve for x when y is equal to 0. So sub 0 in for y and rearrange to get x by itself. So we'll undo the subtracting by 300 by adding 300 to both sides. 300 equals 3 over 2x, and then x is being multiplied by 3 over 2, so divide both sides by 3 over 2. So be careful when you're dividing by a fraction, you actually flip the fraction over and multiply. So you're actually multiplying by 2/3. So 300 times 2 is 600, and 600 divided by 3 equals 200. So x would equal 200 when y is equal to 0. And what does this represent in the question is that in order for them to break even, so to get out of debt, they would have to sell 200 balls. And then anything above 200 balls they would be making profit. So previously in the video, I mentioned what a parameter is. So a parameter is a variable that has a constant value in a particular equation. So they're the letters in the equation that we sub in a number for, and that's the number that stays there. So the slope, the y-intercept. The actual variables, x and y, are the ones that change within the question. So for example, 4a, it says, what is the value of b given y equals 3x plus b and the point -4, 6 is on the line? So that's one way to word this question. I could also say, what is the y-intercept of the line that goes through the point -4, 6 and has a slope of 3? So you'd have to build the equation, putting the 3 in for your m, and then you have your point, which gives you an x and a y value that you can sub in and then solve for b. So from, like I just said, so from the point, x is equal to -4, y is equal to 6, and those are values on the line. So we can sub those into the equation. 6 for y and -4 for x. And then once we sub those in, and the slope is 3, we have only one letter left. And once we have only one letter, then we can solve the equation for that letter. So doing your multiplication, 3 times -4 is equal to -12. And then you can rearrange to get the b by itself by adding 12 to both sides. So 18 is equal to b. So the actual equation becomes, if we sub that back in, y equals 3x plus 18. So that would be the equation of a line that has a slope of 3 and goes through the point -4, 6. This is a very typical question that could be asked for this particular stuff. For part B, given the function w equals mt plus 10, what is the value of m if there's a point on the line at 5, 19? So similarly, the point gives us an x value and a y value because that's a coordinate. So if that point has to be on the line and we sub in those values, y is like the w and t is like the x. So if we sub 19 in for w equals m times 5 and then plus 10, we'd be able to solve this equation for m. So we have multiplication, we have addition, so we have to undo the addition first. Subtract 10 from both sides. 9 equals m times 5, or you can write that as 5m, which looks more familiar. Then to undo your multiplication, divide both sides by 5. So you're left with m on one side of the equation, and 9/5 does not simplify, so that is your slope written as a fraction. So your equation then is w equals 9/5t plus 10. And we leave the w and the t because those are the variables. The m is the parameter that we needed to solve for. In part C, it says in w equals mt plus 10, what is t when w equals 100? So using the equation above where we found the slope, we do need to use that. W equals 9/5t plus 10. They're telling us w is equal to 100, and now we need to solve for t. So sub 100 in for w equals 9/5t plus 10. And solving for t, we subtract 10 from both sides. 90 equals 9/5t. And then t is being multiplied by 9/5, so divide both sides by 9/5. When you're dividing by a fraction, you flip and multiply, so the t is left by itself, and we're left with 90 times 5/9, which is equal to, when you calculate it out, it would be equal to 50. So t is equal to 50 when w equals 100. To verify or check your answer, sub 50 back into the original equation and make sure and solve it for W, see if it gives you 100. So 9/5 times 50 plus 10. And you can go ahead and just calculate that. So multiplication first and then your addition, and make sure W equals 100 to check your answer. Lastly, we're going to look at a word problem using a linear equation. So this is a relation describing the relationship between pressure and like water pressure and depth. So if we're given a table of values here, and they want for part A to sketch the graph, then find the slope of the line. What does it represent? So you're often asked what these values actually mean in the context of the question. Then determining the value of B, which is the y-intercept, and what does it represent. Writing an equation using P and D for the variables in slope-intercept form, and then using it in part E to solve a question. So lots to do in this one. So just a quick sketch of the graph. We're going to have a y-axis and an x-axis. So the x-axis is representing the water depth in meters, and the y-axis is representing the pressure in kilopascals. So after you label your axes, and I do recommend you using graph paper for this, for any graph, and a ruler just to make it nice and neat, then after you've labeled your axes, go and figure out your scale. So my water depth, I need to go up to past 75, so I went up to 100, and going up by 25s as my scale. And then for water pressure, I needed to get past 850, so I went up by 100s for each tick mark, and I went up to 1,000. 100 is a nice scale because 50, like 850, 350 values are exactly kind of in the middle of those tick marks. So then we can go and plot our points on the graph and connect them with a line. So your y-intercept is at 0, 100. You have 25, 350. You've got 50, 600, and 75, 850. Once you have those points, you can use a ruler to draw a nice straight line, and you have an arrow because it does keep going as your water depth could keep increasing. So that's your graph. For part B, determine the slope of the line and what does it represent. So the slope, we can use any 2 points on our line to calculate the slope. So for part B, slope equals y2 minus y1 over x2 minus x1. I like to use the y-intercept because it makes calculating a little bit easier. So 0, 100, and then you can use any other point. So 25, 350 works just fine. And subbing in those numbers, you will have 350 minus 100 for the y values being subtracted, and then 25 minus 0 for your x values in the denominator. 350 minus 100 is 250, and 25 minus 0 is 25. 250 divided by 25 actually equals 10. So for the slope equal to 10, the rise is in kilopascals and the run is in meters. So it's 10 kilopascals change per meter of depth change. So that's what your slope represents. It means for every meter that is descended, the pressure increases by 10 kilopascals. Part C is asking what is the parameter B and what does it represent. So the parameter B is your y-intercept, and we actually were given our y-intercept from the in the table of values. So when x equals 0, the y value is 100. And so what that means is at a water depth of 0 meters, there would be 100 kilopascals of pressure, so at the surface of the water. Part D is to write the equation in slope-intercept form using P for pressure and D for depth. And so when we write our equation, let's do part D down here. Y equals mx plus b is slope-intercept form. Well, we figured out the slope was equal to 10 kilopascals, and the x variable, we're going to use d for depth, so instead of x. So 10 times d, and then plus the b value, or the y-intercept, which was 100, and that's equal to the pressure, which is P in kilopascals. So that's just plugging in the variables that they want us to use to represent the situation and the parameters that we found using our graph. For part E, they want us to solve for the depth, where you would have a pressure of 109,300 kilopascals. So we can use our equation, P equals 10D plus 100, and sub in 109,300 kilopascals for the pressure, which is P. Then you can solve the equation for D. So subtract 100 from both sides. Kind of ran out of room. So we have 109,200 is equal to 10D. Then divide both sides by 10, and D is equal to, there we go, 10,920 kilopascals. Or no, sorry, it's not kilopascals, it is meters. Wrong units. So the D is in meters. So at a depth of 10,920 meters, you would have a pressure, water pressure, of 109,300 kilopascals. So that concludes our video for lesson 7.1. You can use the key ideas here to help summarize the section and then work on the practice questions that follow.